Welcome back to P1. Today we're looking at gradients, tangents and normals, and this is unit 8.6. So today this is where our differentiation in P1 really starts to become useful. Okay, because when I differentiate a curve, that will give me the gradient at any point on the curve. And from that then I can find the equations of tangents and the equations of normals. So let's have a little look what a tangent is. So at any point on a curve, say, and I'll do this in black, but say you get a point here, the tangent is that straight line that touches it and touches it only in that one singular place, like so. Okay, and I can find the tangent at any point on my curve. It's just a line, a straight line that just touches the curve at that one place. Okay, doesn't matter where I'm looking, it's just going to be touching the curve at that one place. And there's a few examples there. Now, the gradient will always give me the gradient of the tangent to the curve. So if I differentiate this curve, so in this case we would have 3x squared plus 6x minus 10, then this is going to give me the gradient at any point. Okay, it's the gradient of the curve at any point, and therefore it's actually the gradient of the tangent to the curve at any point. So substituting a value in, like say this value here, which is a little bit less than a little bit less than 2. If I substitute this value in to this, I will get the gradient of this line. If I substitute this value in, I will get the gradient of this line. If I substitute this value in, I get the gradient of this line. So when I differentiate, I get the gradient of the curve at any point, and this is the same as the gradient of the tangent to the curve at any point. Now, what about a normal? So a normal is a perpendicular line. It's a line that's perpendicular to the tangent. So if I look at one of my points here, and I'm going to draw the normals in red just so that they show out, stand out a little bit better, but this will be the normal at this point. You can see it makes a 90-degree angle there. Okay, normal at this point, and a normal at my final point. So all of these, they make 90 degrees to the tangent. Now, from chapter 5 or unit 5, if you remember, perpendicular lines will have a gradient of 1 over the other line and change the sign, because what I'm essentially looking at is the gradient of the tangent multiplied by the gradient of the normal will always equal -1. So if I've got a tangent that has a gradient of 2, for example, my normal will have a gradient of -1 over 2. If I have a tangent that has a gradient of, say, 3 over 2, my normal's gradient will be -3 over 2. If I have a tangent that has a gradient of -1/5, my normal will have a gradient of 5. So that is what I'm looking at in terms of my normal and my tangent. They are perpendicular lines at that point. Okay, let's have a look at a couple of examples. So looking at this question, we want to find the tangent. So what I want to do first is differentiate. So differentiating this, we get 3x squared minus 4x plus 1. Now it's at this point, so I want to find the gradient at that point, so I'm going to substitute x equals 2 inside. So dy by dx equals 3 lots of 2 squared minus 4 lots of 2 plus 1. And that will give me a gradient of 5. So in this case, I'm thinking that m is 5, and then I know my coordinates are 2 and 7. So what I can now do is use the equation of finding a straight line. Now, you can also use y equals mx plus c, but as I've previously stated in my videos, this is definitely my preferred method. So y minus 7 equals 5x minus 2. Expand my brackets, and then add 7, and then this is the equation of my tangent. Okay, so it's the tangent to the curve at the point 2, 7. Pretty straightforward? I hope so. Okay, in this question we are finding the normal to the curve. So we'll start the same, differentiate, and we get 8x minus 8, and obviously the 1 will be 0. And we have the point x equals 3, so if I substitute 3 into my differentiated expression, this is what I get, 8 times 3 minus 8, and that is 16. Now, this is the gradient of the tangent. We want the gradient of the normal, and that will be 1 over the gradient, so 1 over 16, and change the sign. Now I've got the gradient of the normal, brilliant, and I just need the coordinates, but if I look back up to my question, I've only got the x coordinate. So I actually need the y coordinate, so I need to use the original equation here to find the y coordinate. So we've got 4 lots of 3 squared minus 8 lots of 3 minus 1. 3 squared is 9, and 4 9s are 36. 8 3s are 24 minus my 1, and that should leave us with 11. So my coordinate is 3, 11, and the gradient I want to use is minus 1/16. So equation of straight line, y minus y1 equals mx minus x1. This is y minus 11 equals minus 1/16 x minus 3. Now, in this kind of case, especially when it doesn't tell me in the question whether to leave it in the form y equals mx plus c or ax plus by plus c equals 0, it doesn't say that. So if I've got a fractional gradient, I'll always leave it in the later form. So multiply through by 16 and make my life easier. So 16y minus 176 equals minus 1x minus 3. Now, as I've said before, I normally would have expanded this in one go, but I'm just taking an extra step there so that it's easier to follow. So we get minus x plus 3. So this leaves me with x plus 16y. I take away 3, so it's minus 179 equals 0. And this is a preferred way of leaving it. It's in the form ax plus by plus c equals 0. And we generally leave it in this form when we have a fraction for a gradient. So in the next set of questions, which I'm going to give you to have a go at, if the gradient is a whole number, leave it in the form y equals mx plus c. If the gradient is a fraction, leave it in the form ax plus by plus c equals 0. So here we're trying to find the tangent. Start by differentiating and then substituting a value of x in. So this means we've got 2 lots of 3 plus 5. So 6 plus 5, 11. So I have a gradient of 11. And that is the gradient of the tangent. Now, equation of straight line. Substitute all my values in. And it should be nice and straightforward then. And there we have it, equation of our tangent. Again, finding the tangent, but this time before we differentiate, we need to just rearrange or sort out our equation so that our powers are all on the top, our unknowns, our values of x, they're all on the top line. Now differentiate. And of course, rearrange it. It's better to leave it in this form because it's also easier to deal with. X equals 1. So I'm going to substitute x equals 1 in. So divide by dx gives me 3 lots of 1 squared minus 1 over 1. So 3 ones are 3, minus 1 is going to be 2. So my gradient is 2. Now, I'm given the x value, I'm not given the y value. So I need to find the y value. So find the y value when x equals 1. So now I have a gradient of 2 and a coordinate of 1, 2. So I go to the equation of a straight line and substitute all of my values in. Again, third and final tangent here, so differentiate 9x squared minus 8x. Now we need to substitute x equals half in to find my gradient. So we get 9 lots of a half squared minus 8 lots of a half. So this is 9 over 4 minus 4, and this will give me a negative 7 over 4. And that's my gradient. So my gradient is minus 7 over 4. And my x and y coordinates are a half and minus 3/4. So y minus y1 equals mx minus x1. So we have y minus 3/4. Gradient is minus 7 over 4 and x minus a half. Now what I like to do is I like to multiply it by this, which will also get rid of this one, so it's quite nice. So I'm going to multiply by 4, so I get 4y plus 3 equals minus 7x minus a half. So we got 4y plus 3 equals minus 7x plus 7 over 2. So again, I'm just going to multiply by 2. 8y plus 6 equals minus 14x plus 7. Now I'm going to take everything to the left where x will be positive. So we get 14x plus 8y. And when I take away 7, it gives me minus 1 equals 0. And that's how I would like to leave it in terms of ax plus by plus c. Or y equals minus 7 over 4x plus 1/8 if you left in the form y equals mx plus c. Okay, second question now. So this time you can see we're finding the normal, start the same, dy by dx equals 2x minus 6. Substitute my x value in, so when x equals 4, dy by dx equals 2 lots of 4 minus 6. 2 4s are 8, 8 minus 6 is 2, so this gradient is 2. Now this is the tangent. We want the normal, so the gradient of the normal is going to be 1 over the tangent's gradient and change the sign. And we have our point, and then we go to our familiar equation of a straight line and substitute in everything we know. So negative 8 for y, minus a half for the gradient, and 4 for x. Now I'm going to multiply by 2, so 2y plus 16 is minus. Now I have said before I normally would expand this in one go, but I'm just doing it in an extra step just to make it hopefully easier to follow. Now I always take everything to the side where x will be positive, so that means the left side of the equals, so I'm going to end up with x plus 2y plus 12 equals 0. Alternatively, the answer could be, however, like I've said before, if the gradient is fractional, leave it in the form ax plus by plus c, unless the question states otherwise. So we're finding the normal, and before I can jump in with dy by dx, I need to sort my equation out in a form that I can deal with. So square root of x is a half, it's on the bottom, so to bring it to the top becomes negative a half. Now I can differentiate nice and easy. 2x minus, so this is going to become a plus, 4 times a half is 2x, and then taking 1 away is 3 over 2, or negative 3 over 2. Now we want to substitute x equals 4 in. So that gives me 2 lots of 4 plus 2 times 4 to the minus 3 over 2. Now, if you were doing this without a calculator, you'd probably put that 4 on the bottom to the 3 over 2, or you can use your calculator, but to the power 3 over 2 is just square root it and then cube it. So that's going to give me 8, and 2 over 8 is 1/4. So I have 8 plus 1/4, and that is 8 1/4, or 33 over 4. Now that's the gradient of the tangent, so the normal gradient will be 1 over that, so flip the fraction and change the sign. Now you can see we've got the x coordinate, but we don't have the y coordinate, so we need to substitute that into the original equation. So that gives me 4 squared minus 4 over root 4. Well, root 4 is 2, 4 over 2 is 2, so I've got 16 minus 2, so it's going to give me 14. So my coordinate is 4, 14. And then, very standard, y minus y1 equals mx minus x1. Notice that I always write it down, and I do that because it makes sure it stays in my head. I doubt I'll ever forget this equation at this point. Now, in the past, I've always said, multiply by this 33, and you can see questions like this, it generally is easier, although 33 times 14 is not so easy. So I could leave it as a fraction, but I am still going to multiply by 33 here. So that gives me 33y minus 462 minus 4x plus 16. So it's 4x plus 33y minus 478 equals 0. And there we have it in the form y equals mx plus c. Okay, third one from part 2, we can see we are finding the normal, and first thing I want to do is sort out my equation here into a form that's easy to deal with. So that will be 2x over x minus 3 over x. These will cancel, so it's 2 minus 3 over x. Now I also need to take that x to the top, and there we have it. So this is going to give me minus 1 times minus 3 is 3x to the minus 2, or 3 over x squared. And I need to substitute x equals 4 into here. So that is going to give me dy by dx equaling to 3 over 16. Now, we've got the x coordinate, we don't have the y coordinate. So let's also work that out. So it's 2 lots of 4 minus 3 over 4. It says 8 minus 3 is 5. It says 5 over 4. Now, you see what I just did there? I went on to find my x coordinate without finishing off and getting the actual gradient of this normal. It's can be dangerous doing it like that, because you might forget that you need the gradient of the normal and not the tangent. You might forget to change this. Okay, so always finish off your gradient before moving on to anything else. Now, very simply, y minus y1 equals mx minus x1. So we've got y minus 5 over 4 equals minus 16 over 3 x minus 4. Now, I'm going to multiply through by 12 so that it's a little bit easier for me to deal with. So I get 12y minus 15 equals minus 64x plus 256. I always remember stuff like that from computers. So 64x plus 12y, we're going to minus the 256, and that'll give us minus 271. Alternatively, okay, question 3, we are finding tangents to the curve at 2 points. So let's take the curve and differentiate it first. 3x squared plus 6x minus 10. Now, when x equals negative 4, my dy by dx is going to be 3 lots of that minus 4 squared plus 6 lots of minus 4 minus 10. And that will give me 14. So for my first tangent, the gradient is 14 and the coordinate is negative 4 and 24. So my minus y1 equals mx minus x1. Y minus 24 equals 14x minus minus 4. So y minus 24 equals 14x plus 56. So y equals 14x plus 80. And that is the equation of my first tangent. Okay, so we left that first tangent in red. Now we're going to work out where the gradient and the equation is when x is negative 3. So dy by dx equals 3 times minus 3 squared plus 6 lots of minus 3 minus 10. And that gives me negative 1. So my gradient here is negative 1 and my coordinates is minus 3, 30. So as per usual, put down the equation in a straight line, substitute in what you know. Expand and simplify. So we get plus 3 times minus 1, so minus 3 there. So So y equals minus x plus 27. Now I have my two tangents. My first one in red, my second one left in black. Now I need to find the point where they meet, so I need to equate these two equations. So that gives me 14x plus 80 equals minus x plus 27. So 15x equals minus 53. So x equals minus 53 over 15. Now then, I've got my x value, not very nice, but we've got it. And I can substitute it into either equation to get my y value. I'm going to use the second equation. So we get minus 53 over 15 plus 27. That then gives me 458 over 15. So my coordinates where they meet are negative 53 over 15, 458 over 15. All to two decimal places. I've just put that in red just to give you an idea. Okay, very similar to the last question. This time we're looking at the normal equation to the curve. So differentiate gives me 2x minus 5. And then we need to look at when x equals 5. And that gives me 2 lots of 5 minus 5, which is 5. That means then the gradient of the normal will be change of sign and 1 over. So minus 1/5. So I'll put it up here, minus 1/5, and the coordinates 5, 4. So using equation of a straight line, we got y minus 4 equals minus 1/5 x minus 5. Now, I do normally like to multiply up by this 5, but in this case, because we're going to equate them to see where they meet afterwards, it's easier if I leave it in the form of y equals mx plus c. So that's what I'm going to do. And then we're left with minus 1/5 plus 5. For my second coordinate, so when x equals minus 1, dy by dx is 2 lots of minus 1 minus 5. So that's minus 7. So my gradient will be a positive 1/7. And the coordinate is minus 1, 10. So taking my y minus y1 is x minus x1. We get y minus 10 is 1/7 x minus minus 1. So y minus 10 is 1/7 x plus 1/7. So y equals 1/7 x plus 71 over 7. And here I have my two equations of normals. All that's left is to equate my equations. So minus 1/5 x plus 5 equals 1/7 x plus 71 over 7. Now I'm just going to multiply through by 35 to make my life a little bit easier. You don't have to do this, just to get rid of my fractions. Okay. There we are, and that gives me 12x on this side and negative 180 on this side. So that means that x equals negative 15. And once I've found the x value, I can substitute it into any of my two equations to find my y value. I'm going to put it in this one with the 5s, as I think that will be easier to deal with. So y equals minus 1/5 times minus 15 plus 5. So you can see that this is 3 plus 5, which is 8. So my coordinates is minus 15, 8. So we know point P has x coordinate half, and it's a normal that is going through that P and Q. So let's start by finding the gradient of the curve, and that's going to be 4x. And when x equals a half, the gradient here is going to be 4 times a half, or 2. That means the gradient of the normal is negative a half, and the coordinate is 1/2, and I just need that y value. So if I look at the equation, I get 2 times a half squared. Half squared is a quarter, 2 quarters is a half. So here is my coordinate. So the equation of the normal is y minus y1 equals mx minus x1. So we have y minus a half equals minus a half x minus a half. Now again, I'm going to keep this in the form y equals mx plus c. And the reason for that is that I'm going to need to equate it with this one later. So y equals minus a half x, adding a half gives me 3/4 there. So that is now the equation of the normal through P and Q. Now what I need to do is equate it with this equation of the curve to see where they intersect. We already know one point, we just need to find the other. So equating these equations, we would get 2x squared, and that's equal to negative a half x plus 3/4. Now I'm going to multiply through by 4 to make my life a little bit easier, and that will give me 8x squared minus 2x plus 3, 8x squared plus 2x minus 3 equals 0. Now I need to go about factorizing this. Now I know that one of the equations, or one of the coordinates, was a half earlier, so that has to come from a 2x minus 1. That makes my life a little bit easier. So it's got to be 4x and it's got to be a plus 3. And just double checking, 8x squared, 6x minus 4x is 2x, and minus 1 times 3 is minus 3. So it does work fine. So we get 2x minus 1 equals 0, x equals a half, 4x plus 3 equals 0, x equals negative 3/4. This is now our value for Q, as we already had the half. So I'm going to substitute this into my equation of a curve because that's the easiest one. So y equals 2 lots of minus 3/4 squared, and that gives me 9/8. So my coordinates of Q are minus 3/4 and 9/8.